11-2, the Pythagorean Theorem, Part 2. Okay, just want to do a quick reminder here. Remember, this only works with right triangles. So do not attempt this with other type of triangles. Nausea, vomiting, stomach cramps may ensue. So how do you know if it's a right triangle? Usually it's going to have a little square in the bottom or somewhere in one of the corners, and that indicates it's a 90-degree angle in that corner, or it'll say 90 degrees, or they'll tell you in the problem. Remember, you have two legs. The two legs are the sides that are connected to the right angle. The side opposite of the right angle is known as the hypotenuse, and the legs are also can be known as A and B, with the hypotenuse being C. So what we try to remember here is A squared plus B squared equals C squared. So let's use some problems that are kind of real life here, situational problems. And here we have a rectangular park, and it measures 300 feet by 400 feet. We want to put a sidewalk from one corner from the other diagonally. Find the length of the sidewalk. So here's a picture. We got our green grass, all kinds of good stuff. So we want it to go, a sidewalk to go right down through the middle, cutting it in half. Well, that creates what? Two right triangles. So we're going to use our A squared plus B squared equals C squared to find that. How long does that sidewalk need to, or will be? And this would probably be a good time to mention that you can use calculators on this. So I don't mind if you bring a calculator to class to solve the problems, or if you use a calculator at home to solve the problems. These get to be kind of big numbers, and I want you to be able to focus on what you're doing, not on the arithmetic. So if we square those out, we get 90,000 plus 160,000 equals C squared. Add them up, you'll get 250,000 equals C squared, or the proper way to say that would be 250,000 equals C squared. Take the square root of both of those. Remember, we're not going to worry about the negative square root because we're talking distance here, so we don't have to worry about that. And we'll get C is equal to 500 feet, so the sidewalk is 500 feet long. Next one, find the missing side of the right triangle below. Plug in as much as you can. Go ahead and go as far as you can. This one does have a little trick to it, so if you get stuck, that's okay, but at least try to set it up. Okay, again, we're going to use A squared plus B squared equals C squared. This time we have one leg, and the hypotenuse. So we have 5 squared plus x squared is equal to the square root of 146 squared. Actually, I don't think I said that correctly. It should be the square of the square root of 146. I believe that would be more proper. So we square those. We get 5 squared is 25. X squared will stay the same. And the square root and the square are going to kind of cancel each other out, and we get 146. Subtract 25 from both sides, keeping our equation balanced. The 25s will zero out, and that'll leave us x squared is equal to 121. And either using your calculator, or if you use your chart on the previous guided notes, you could see that if we square that, we get 11. Number 3, a 26-foot ladder leans against a wall. How far must the base of the ladder be placed away from the wall if it is to reach a height of exactly 24 feet? So how might this be useful if you decide you want to be a window washer and you need to put the ladder right below the window so you can wash it? If you don't put it in the right spot, you won't be able to reach the top of the window. And if you put it too close, you might end up hitting the window and breaking the glass and getting fired. That's not a good thing. We wouldn't want that. So here's our wall. Here's our ground. We're going to place our ladder, and we want it to be in just the right spot so it's at the right height. And we know that the ladder is 26 feet. We know that we want it to touch at exactly 24 feet. So we need to know how far away are we placing it. Bring in the Pythagorean Theorem. We're going to assume that the wall is 90 degrees from the ground, otherwise that's not a very good structure. So they give us a hypotenuse. They give us one leg. So we have 24 squared plus x squared is equal to 26 squared. Pull out those calculators, square those. We get 576 plus x squared is equal to 676. Subtract 576 from both sides. We get x squared is equal to 100. This one should be familiar to you. You should have this one down. Remember, there are two possible answers, a positive and a negative, but since we're talking distance, we are only concerned with the positive. And we get x is equal to 10. Number 4. A guide wire is needed to support a 9-meter pole. How long should the guide wire be if it is to be fixed to the pole, fixed to the ground 6 meters from the base of the pole? So here's our pole. We're going to attach a wire to it. We know the pole is 9 meters tall. We know that we want it to be 6 meters away from the base of the guide wire to the base of the pole. So I'm looking at what looks like a right triangle here. So we have a squared plus b squared equals c squared. Plug things in. We get 9 squared plus 6 squared is equal to x squared. 81 plus 36 equals x squared. X squared equals 117. Now we're probably going to want to pull out our calculator. And if we take the square root of both of those, we're going to get x is approximately 10.8. You're going to want to round, just like the previous lesson, round to the nearest tenth, if needed. Now, remember, if it's a right triangle, if a squared plus b squared equals c squared, the converse, or kind of going backwards of the Pythagorean theorem, if a squared plus b squared equals c squared, then it's a right triangle. So if you want to figure out if a triangle is a right triangle or not, if you plug in the sides, then square them, then it should work. So let me give you an example. Now the one thing you need to remember is the longest side is always the hypotenuse. It's always going to go by itself. So doesn't matter the order. The order just doesn't matter. What matters is what's the longest side. It's the hypotenuse. So we're going to plug these in to a squared plus b squared equals c squared. So I'm going to plug them in. Well, I can do it pretty much just as they are because 15 is the largest. And notice how I put a question mark there because I'm not sure if these are equal. So I get 81 plus 144. Does that equal 225? Yep, it does. So that is a right triangle. Now if I try these, now remember, the longest side is the hypotenuse. So I'm going to take that 7 and put it for the c squared. So is 3 squared plus 5 squared equal to 7 squared? Well, that gives me 9 plus 25. Does that equal 49? Nope, equals 34. So 34 is not equal to 49, in case you didn't know. So this is not a right triangle. It can be a triangle, it's just not a right one. Would you try this one? Is this a right triangle? So you're going to plug it into the Pythagorean theorem. So I'm going to have 7 squared plus 11 squared. Is that equal to 12 squared? 49 plus 121. Does that equal 144? It's not sounding like it. Add that up. I get 170 is not equal to 144. So this is not a right triangle. It can be a triangle, just not a right one. Would you try this one and decide, is this a right triangle? So we'll use our Pythagorean theorem. Now remember, the biggest number has to go by itself. So I've got, is 5 squared plus 12 squared equal to 13 squared? In other words, is 25 plus 144 equal to 169? Nope. They do not add up, so, or sorry, what am I saying? Yes, they do. Yes, they do add up, so this is a right triangle. Would you try this one? Decide if this is a right triangle. So we have a squared plus b squared is equal to c squared. So we'll have 8 squared plus 15 squared. Is that equal to 17 squared? I'll add those up. 289 equals 289. So yes, this is a right triangle, as I'm sure you are so excited to find out. Now this one, a little tricky. Is the square root of 40 bigger or smaller than 5 and 8? Well, it's approximately 6.3. So it's smaller than the 8, which is all we really care about. So that tells us that the 8 is the hypotenuse. So we'll have 5 squared plus the quantity square root of 40 squared. Is that equal to 8 squared? Well, that's 25 plus 40. Does that equal 64? No, but this is probably pretty close to a right triangle. It's just not quite there, but it's close. And that's it for today, as I do a big yawn. It's been a lot of fun. So if you have questions, post them on Edmodo or bring them to class, and I'll be happy to answer them. Have a wonderful day, evening, weekend, whenever you're watching this. So thank you. Goodbye.